In this video, we are going to talk about the assembly program that utilizes arithmetic operations in a sum. So what this program basically does is it prints out the 5-digit code based on the different clues or hints that was given in the problem. So now let's proceed in line 11. We have here include ASM IO.INC. So what this means is we are gonna link another INC file in our program, since this includes different input-output functions that we'll be needing in our ASM. Because the ASM itself doesn't have that feature, that's why we're going to link it with another file. In line 13, we have this block which has values, directives, and the variable name. So for here in from line 15 to line 20, we have these variables that will compose the printing out of the whole problem. So it will just be printed out in the output or at the end of the program. In line 23 to line 29, this is the output or where the code will be printed out. So the 5 code is here, or the 5-digit I mean. So we're looking for the 5-digit. So we also have 5 strings that will be printed out every time we reveal another digit. In line 32, we have this segment.bss, which is a block of uninitialized data. What do you mean by this? So if you compare the segment.data and segment.bss, it doesn't have a value in BSS. Since BSS, we still don't know what to put in our variables, and later on as the program continues, that's where we'll know what values should we put in. So we have a variable for the first number, a container for the second number, third, fourth, and fifth. And now let's start with our segment.text. So this is like the starting point of everything. We have this global to tell the function or the program that this will be the start of everything in ASM main. And now let's proceed with the main function. So in line 43 to 44, we have this enter 00 push 8. So this is like a fixed setup routine in our ASM file. So this is the only way we could start our program in ASM. In line 46, we have this 8 stored in the register EAX. So where did we get the 8? So going back in our hint, we have this first 2 digits adds up to 8. So this is where we got the number 8. And from the hint of being an addend of 8 and divisible by 6 when multiplied with another number, we know that the first number now is 3. Since first number is used in second and third clue, which adds up 2 digits adds up to 8, and the middle digit is the quotient when the product of the first and last digit is divided by 6. So it should be an addend of 8 and divisible by 6. And we know that the number 1 to 5, since this is the only digit that is allowed, that has that character or that has that condition, is only 3. Here pala. So we put in the value 3 in our register EBX. Then we use the subtract function, so EAX minus EBX, and this will be stored in register EAX. That is why the answer for this one will be the second number. And that is why we got the value of EAX and transferred it to the second number. So that's the difference. So 8 minus 3, which is 5. 5 will be transferred here. This is 5 now. 5 will be transferred or located in our second number now. In line 54, we just simply used the EBX or called on the EBX register, and whatever the value inside the EBX will be stored in the first number, which is 3. In line 56, or in line 57 rather, we've called on the value for first number and stored it in EAX. So why? Because according to the clue, the fifth number multiplied by first number must be divisible by 6. So we are going to use the first number, and now we're looking for the fifth number now. So from 1 to 5, we already have the first number to be 3 and the fifth number to be 5, or the second number rather to be 5. So the only options that we have left is 2 and 1 and 4. So what values should we use that is multiplied by 3 that could be divisible by 6? So one thing, or the most suitable number is 4. That is why we've stored this here in our register ECX. Now we'll multiply 4 with our first number, which is 3, so that is equal to 12. 12 will be stored in register EAX from line 59. In line 60, we have stored the value 6 in register EBX. Why? Because the product here will be divided by 6, and we need to store it first in the register so we could use the function IDIV. Now in line 61, just simply gonna divide 12 with 6, and in line 62, this is where the third number rather will be stored. So the third number for this one is 12 divided by 6, which is 2. In line 63, we have the fifth number, so we just simply get the value here in ECX since we've set it to 4. So the value of ECX here is 4, and 4 will be transferred in our fifth number. Now we have the first, second, third, and fifth number. We only have fourth number left to be answered. In line 65, we have this store the second number to our EAX register. Since in the hint we have this difference of the second and fifth digit is equal to the fourth digit, so we're gonna use the second digit and the fifth digit. So here in line 65, the second number is stored in EAX register, and we don't need to store fifth number anymore since it's already here and it's in ECX register here. So just simply subtract this. So EAX minus ECX, or 4 divided by minus 3 will be equal to 1. So the store value of fourth number. So the value of EAX here, which comes here now, will be stored in our fourth number. So from line 71 to 87, this is just basically printing out the whole statement or paragraph of our question or our problem. In line 90 to 94, this is just a printout statement for the first digit. In line 96 to 100 for the second digit, and so on and so forth up to line 119. So they're just printing out the information or necessary statements for every digit in our code. But from line 121, this is the final message wherein it will print out the code is and the next space and next series of connected digits now. So like if the digit is 54321, they're in the same line but has spaces in between them. And in ASM, we don't have like automatic spaces in between them. We need to call out another function or another variable and call print string. So we've defined here a space variable, which includes a space inside, so that the printing out of the result will be clear and concise. In line 146 to 151, this is just in line 146 to 153, this is like just a fixed exiting point. So as you can see here, we have defined, we've moved the register, we've set the 3 registers that we've used back to 0, and then we'll leave and return to C. So now we are going to in our Linux. So what we're going to do first is we call on this function f of the f type is io.asm. Next is our file, which has the file name cgv. Next is our GCC driver, cgb, then driver.c, cgb.osmio.o. Now we can finally run our program since we've already compiled it and linked it with our driver. So this is the answer for our assembly program lab 1. Thank you for watching.